Afvat hy. Right, kom ons gaan gou aan. Ons is nou besig met die pompe. We're busy with our pumps. 'n Draaiskroefpomp. Waar word hierdie pompe gebruik? By baie diep boorgate. Wat is die funksie van hierdie pomp? Om krag vanaf die engine na te pomp. Of van die pompkop. Wat is die funksie van die surfrooster? All of this we've already gone through. Ons het klaar gekyk wat is die voordele en nadele. Hulle sê so, die lewering van 'n draaipomp is direkte verhouding met die pompspoed. Verhoog en verminder die pompspoed vir meer en minder water. Now we said this yesterday, this is our screw pump. It's also a lot more expensive. It's baie duurder. It's going to cost you more money to do this with a screw pump. But it is the better one because you can control, like we learned yesterday at Delheim, how much water do we need? We can't flood irrigate because it will flow away. En wat het ons by Delheim geleer? Hulle irrigate glad nie. Het werk met reën. Maar behalve vir 'n paar lande. Maar met hierdie pomp kan jy stel hoeveel water pomp jy in 'n dag. So you can set the amount of water that you pump out in a day by using this pump. Yes, Piet.
Meneer na reën teenoor bespring. Wat sê ons sal vinniger dra of meer dra?
Kyk, reën is jou natural way. En Delheim se hele ding agter die storie is hulle wil natural boer. Okay? Maar beskroeiing gaan vir jou meer laat dra. Maar nou, wat het ons gister geleer? Quality over quantity. Because in places like the Orange River, where they flood irrigate, they have huge amounts. The quantity is huge, as baie. But the quality is shit. That's papsak wyn. Hy sien verskil tussen wyn in 'n box en wyn in 'n sak. You understand? Wine in a bottle and wine across the road there in the oliekannetjie. Daar is die verskil. So met besproeiing, Cornel, kan jy goeie oplewering doen. Maar hulle het ook vir ons gesê, Delheim het gister vir ons gesê dat die Orange River kellers het toegemaak. Want hulle maak nie meer wyn daar nie. Die kwaliteit wyn is te swak. Even if 80% of the country buys a papsak, it's not enough to make money. So they're going to cut that. They're going to only go to tafeldrywe, to grapes you can eat.
Ja, ek het gehoor daarvan meneer, my oom is besig
om dood te maak. Nadele.
Hy is besig om materiaal vir hulle want ons is hulle het al klaar daar begin.
Okay.
Met vir tafeldrywe insit.
And the next one, die nadele, all the negative sides. Die pomp moet vanaf 'n oppervlak met 'n skag aangedryf word, so there must be a shaft to run this pump. Die pomp moet altyd in dieselfde rigting draai om te voorkom dat die stange losdraai. You can't let the pump go clockwise then to anti-clockwise. Then it's going to rip out the whole shaft. Yes. And here is our sketch vir die Afrikaanse laities. Dit is alles vir julle getik in julle boek. En die Engelse laities, die sketches in Engels, so julle sort dit. Yes.
As jy dan gate moet maak, kos
Okay.
veel geld.
Ja, dit kos 'n
So
paar.
meneer, jy kan die net gebruik by 'n boorgat.
Yes.
So jy kan hom nie met soos 'n gewone pomp gebruik nie.
Ja, hy is die pomp self.
Ons pompe gesing het net water gevat, 'n klomp water uitgepomp en dinge sin.
And now we come to the national sport of Jan Kriel, centrifuge pump stealing. Die centrifuge pump. Ja, nee. Ja, nee. Beskryf die werking van 'n centrifuge pump. Soos hulle gesê het, die steier, the level, hy draai vinnig in 'n rigting wat deur die pyl aangedryf word. Ek het daar op die pyltjies op die skets vir julle gewys word. Die vinne van die steier forceer die water deur die uitlaatpyp. Die water wat uitbeweeg word vervang met water wat aan die pomp opgesuig word via die voetklep en die suigpyp wat aan die inlaatpyp gekoppel is. Hierdie aksies is moontlik omdat daar geen lug binne in die stelsel is. So there must be no air inside the system, otherwise the centrifuge pump does not work. In Afrikaans praat as hy sluk lug.
Yeah.
It makes a bubble in your pipes which messes up your pipes and you think your house is haunted, but it's water.
Die pompe bloei maar wat het hulle daar veel gesê? Ek het nie lekker verstaan.
Ja, sal daar uitkom. Waar hierdie pomp, waar gebruik ons dit? Where do we use this? For river irrigation, vir water uit strome, water uit damme en water uit putte. So we use this to get water out of dams, out of streams, out of rivers and out of pits.
Kan jy hom gebruik uit tenke uit?
Yes. Hey?
Multi-purpose.
Pools as well. Centrifuge pump kan vir 'n swembad gebruik. If it goes very, very bad in Cape Town, 'n lekker glasie pool water, my vriend. Ja, this is the cheaper pump. Hy's 'n bietjie goedkoper, maar hy hou nie so lank nie, hoor. Goedkoop koop, duur lewe.
Okay, nou besien se sit ons pad hulle water.
Kom ons gaan dan. Noem 9 aspekte van die aanmerking geneem moet word voordat jy besluit oor watse pomp gebruik. Before I buy a pump, what do I need it for? Waarvoor gaan ek dit gebruik? Vereistes. What do I need the pump to do? Watergehalte. What is the quality of my water? If I have crap water, it's going to mess up my pump. If you've got a sandy water, then it's not worth, like this river here. Ugh. Yes.
Toe ons system wat insit het hulle ons gesê ons moet eers water gaan toets om te sê
yes. Wat is soort systeem jy kom? Beskikbare soort aandrywing. How can I run my pump with electricity, with a generator, with a bicycle? Jy moet eens uitfigure hoe gaan ek my pomp hardloop. Mobiliteit van die pomp. How mobile must the pump be? Moet ek hom kan uithaal en skuif of moet hy op 'n punt staan? Must it stay in its place or must be able to move it? South Africa try to move it. Eenvoud van die konstruksie. How easy is it to build this and how is it constructed? But remember, you work with farm workers that not really fully educated. If it's something easy, then you install it. As dit maklik is, installeer dit. Maklik regmaak. Aandag wat dit vereis. How much time and maintenance am I going to spend on this pump? Hoe lank gaan ek werk aan die pomp? Koste en beskikbaarheid van onderdele. Are the parts available in my area where I live? If I live in Piketberg and I buy a pump from Beijing, China, how am I going to get the pumps from China to Piketberg? Via BAT or COVID? I don't know. Dit hang van jou af. Okay?
Mag ek COVID sien op YouTube?
Ek mag nie sê coronavirus nie. Self-installering, can I put it in myself or should I get somebody in? Remember, we as farmers want to put it in self. Julle het mos gesien, die John Deere saak wat aangaan. Die farmers beklei om hulle eie goed reg te maak.
Ja, maar dan weet ons hoe dit werk.
Pragtig.
Want dis elektroniese rubbish wat krap op die goed.
There's the pump sketch with all our parts. Grease nipple. Right, and then standard general questions. Hierdie algemene vrae, you'll also have this in your book, is general questions that we can ask in the exam. Okay. Noem 4 veiligheidsmaatreëls wanneer ons met 'n pomp werk. Maak seker dat die oorbelastingsveiliger en aardklepbeskermer werk. Elektriese lasplekke. I'm not going to go through the whole thing, but there is questions that I can ask you in the exam at the end of the year. So now, to make it a bit more fun, because we've got all of these little sketches there. Okay.
Dis eintlik die grade wat jy moet nou die grade is die ding wat eintlik veilig as nie veilig is.
Ag. Vandag die klank aansit, sorry julle. Die help dat ek dit nou klank maak, weet jy. Julle kan nie hoor wat ek sê nie.
All of its main components, how it works, some of its design features, and the advantages and disadvantages associated with this type of pump. So here is a rotary vane pump. This particular pump is quite small. It looks like it would connect to a 220 volt supply. It's used for aeration, so it's going to be pumping air, but we can also use vane pumps in hydraulic systems and also for creating a vacuum within a system. Let's load up the labels. We can have a look at some of the components. So we have our motor. That is this section here. We have our shroud. We have an end plate, this item here. We've got an inlet and a outlet end cap. This is the inlet cap and the outlet in the background. We've got a muffler box. That is this whole piece around here. We've got an external filter which we use to draw air into the pump. And over the back, we've actually got the main discharge, and that would be through this pipe here. The gasket is a static type seal which has been installed between the muffler box and the end plate. If we take a cross section, then we can have a look at some of the internal components as well. So we can see some of the internal components. I'm just going to get rid of the amber gasket. We've got a rotor. That is this round item here.
Circle.
That is a Nazi symbol.
We've got the vanes. There's 4 of them.
Dit op YouTube
One
sê
here,
jy nou.
one here, another one here, and one there. And then we have a cam ring, which some people also call a stator. And that is this entire piece around the outside here. The stator in this pump is stationary, whilst the rotor rotates. Now we've learned the names of some of the components, let's see if we can figure out how it works. You can see we've got our external filter. That's where we're going to draw air into the pump. Because this type of pump is very sensitive to foreign particles and abrasion, we're actually going to have an additional filter inside the muffler box. We can see the air flows in through the filter here, is discharged through the base of the filter, and then passes through a secondary filter here in order to reach the suction port of the pump. We take away the end plate, we should be able to see the suction port underneath. So the air has passed through the external filter, now the internal filter, and it will be discharged in this space here, which is the suction port of the pump. If we take a cross section, we'll be able to get a much better view of what's happening inside the pump. And I think this time we can actually take away some of the labels, which we no longer need. When the air or fluid, in our example we're using air, but it can be another fluid. These pumps are often used for hydraulic fluids as well. If we back it up, we can watch what happens as the fluid flows in. It will say the air comes in here, and it's going to fill up the entire space between one vane and the other vane. As the rotor rotates, we're going to seal off the space between the two vanes, and then as the rotor continues to rotate, the vanes are going to turn, and we're going to open up the discharge port. Notice now that the discharge port is open, and we're going to displace or force out all of that fluid, all of that air into the discharge port. The reason this occurs is because gradually the space, the volumetric space in this area is decreasing, whereas on the opposite side, on the suction side, the volumetric space was increasing. Let's just play that through. We're discharging the air. It's completely discharged. We'll go around here, and then we're going to be sucking air back in on this side, completely fill this chamber, force the air around. This may also be a fluid, remember, maybe a hydraulic fluid, etc. And then begin to discharge the fluid on the opposite side. And in this manner, we can create flow. And that's exactly what pumps do. This particular type of pump is a positive displacement pump. That means it can pump air, whereas a centrifugal pump, for example, cannot. Notice that the vanes on our particular pump are simply sliding in and out of the rotor due to centrifugal force. It is, however, possible to use hydraulic pressure to force the vanes outwards against the cam ring, or to use springs. Notice that the rotor is offset compared to the position of the cam ring. It's slightly elevated above the center line of the cam ring. If the rotor is offset, it means that we can draw fluid in here and discharge it on the opposite side, because there's a changing volumetric space from one side to the other. If we were to push the rotor onto the center line of the cam ring, then there would be no flow, because the volumetric space around the entire rotor and the cam ring would remain constant, so there would be no reason to get flow. Now, this particular type of vane pump is known as an unbalanced fixed displacement pump. It's unbalanced because the rotor is offset. That means that there are additional loads transferred to the pump shaft. For this reason, the pump's known as unbalanced. It's also possible to have a balanced vane pump, where the rotor sits in the middle of two eccentric cam rings. There'll be two inlets and two discharges. For example, an inlet here, and then a discharge, and then a discharge, and an inlet. Because the rotor sits in the middle of two eccentric cam rings, and because there are two inlets and two outlets, we have a balanced rotary vane pump. So just remember that if the rotor sits offset to the cam ring, and there is one inlet and one outlet, then it's an unbalanced pump. If the rotor sits in the middle of two eccentric cam rings, and there are two inlets and two outlets, then it's a balanced rotary vane pump. We can see on our pump that the cam ring does not move in relation to the rotor. That means that if the speed of the pump remains constant, so does the flow rate. This is a fixed delivery pump. We're always going to be displacing the same amount of fluid for every rotation that we make. There is, however, a slightly different design that you may see, and this design is called variable displacement or variable delivery. We can vary the delivery rate of the pump by varying the position of the cam ring with respect to the rotor. If we were to move the cam ring upwards, then we would decrease the delivery rate of the pump. Remember that if the rotor sits directly in the middle of the cam ring, we get no flow. And by pushing the cam ring upwards, we're going to position the rotor more in the center of the cam ring. That means that as the cam ring is moved upwards, the flow rate will gradually decrease until the rotor is perfectly in the middle of the cam ring, and then there will be no flow whatsoever. But how do we force the cam ring upwards? Well, we can do that by connecting a hydraulic piston onto the discharge side of the pump. The connection will come around and we'll have a piston on the lower side, and if the discharge pressure increases too much, then the piston will push the cam ring upwards, the rotor will move more into the center of the cam ring, and the flow rate will decrease. When the discharge pressure reduces again, the piston will move downwards, and the cam ring will move back to its original position, because on the opposite side, on this side here, there will be a spring. So it's the hydraulic piston, which is controlled by the discharge pressure of the pump, which forces the cam ring upwards, which puts the rotor more into the center of the cam ring, which in turn reduces the flow rate through the pump. As the pressure on the discharge side decreases, the spring pressure on the top of the cam ring will push the cam ring downwards because it can overcome the hydraulic pressure in the piston. And in this way, we can vary the delivery rate of the pump. So two different designs: the fixed delivery rate pump, like the one we see here, where the cam ring is stationary in relation to the rotor, and the variable delivery design, where we use a hydraulic piston to adjust the position of the cam ring in relation to the rotor, and then we'll use a spring to return the cam ring to its original position once the hydraulic pressure decreases. As with all pumps, there are advantages and disadvantages, and the rotary vane pump is no exception. The rotary vane pump is a type of positive displacement pump. They're self-priming, have very low pressure pulsations, and are efficient. They're also suitable for a wide range of pressures and temperatures. In addition to that, rotary vane pumps are also quiet compared to other types of pump. There are, however, some disadvantages. The pump itself has quite a complex design compared to other pumps, and because of the tight seals between the vanes and the cam ring, the pump is very sensitive to foreign particle ingress. For this reason, additional filters are required on the suction side to remove any fine particles that may damage the internals of the pump. This type of pump is also not suitable for pumping abrasive liquids. So you now know all of the main components associated with a rotary vane pump. You know how it works. You know some of the main designs, such as unbalanced and balanced. and fixed delivery rate and variable delivery rate. And you also know some of the advantages and disadvantages associated with this type of pump. If you want to learn more about rotary vane pumps or other engineering related topics, then check out some of our engineering video courses. Our video courses cover everything from combustion engines to valves to pumps to power stations.
Kyk, daai het julle vorm, julle kan 'n bietjie daar gaan krap. Jy sou moet
Meneer, is dit eigenlijk een vacuum met hulle in die pomp maak jy met dit?
basies ja,
Dit is een vacuum cleaner.
amper.
Vacuum cleaner werkt op ander
Hy werk net anders op.
Nou. Met een vacuum cleaner kan je wapen maken.
Ja, je zit hem in reverse en je zit iets af in zichzelf.
Nee, jy
Rotary pumps.
Jy sit 'n vacuum in daai tube. Jy sit 'n balletje daarin. Jy trek
There are 4 types of rotary pumps: screw pump, gear pump, lobe pump, vane pump. In screw pumps, it is the intermeshing of the threads on the rotors and the close fit of the surrounding housing that creates one or more sets of moving seals in a series between the pump inlet and outlet. These sets of seals or locks, as they are sometimes referred to, act as a labyrinth and provide the screw pump with its positive pressure capability. The successive sets of seals form fully enclosed cavities that move continuously from inlet to outlet. These cavities trap liquid at the inlet and carry it along to the outlet, providing a smooth flow. The pump is so named because it has 2 gears that are side by side or external to each other. A drive gear that is driven by a motor rotates an idler gear in the opposite direction. When the gears rotate, the liquid which is trapped.
Nou sien julle hoekom moet die water skoon wees. You see why the water must be a clean and good quality. Because if that gearbox is damaged with stones or sand, gehaal hom uit mekaar uit. Ek wil sien hoe hierdie Engelse kinders gaan later Afrikaans praat. So moeilik is dit om hy ding uit mekaar uit te haal. Gaan speel met hom 'n bietjie. This gets expensive and dangerous.
Meneer, kom probeer, ons het gaan nie experimenteer met hom en dan haal ons hom uit mekaar.
Yes, Jan. Kom hy nou.
Trapped in the gear teeth spaces between the housing bowl and the outside of the gears is transferred from the inlet side of the pump to the outlet side of the pump. The meshing of the gears on the discharge side of the pump forces the liquid out of the pump and into the discharge piping. The lobe pump receives its name from the rounded shape of the rotor radial surfaces that permits the rotors to be continuously in contact with each other as they rotate. Lobe pumps can be either single or multiple lobe pumps and carry fluid between their rotor lobes much in the same way as a gear pump does. Unlike gear pumps, however, neither the number of lobes nor their shape permits one rotor to drive the other, and so all true lobe pumps require timing gears. Vane pump includes a rotating cylinder containing equally spaced radial pistons arranged radially around the cylinder center line. A spring pushes the pistons against the inner surface of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid during half a revolution and drive fluid out during the other half. The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are: gear pumps handle more viscous fluids. The sliding vane pump suits both viscous and non-viscous fluids. Sliding vane pumps cannot handle dirty or gritty liquids. Vane pumps are ideally suited for low viscosity, non-lubricating liquids. Sliding vane pumps are used for vacuum services. Load pumps are used for food and beverage processing. Load pumps can handle both low and high viscosity fluids.
Ai. Daar het julle vir hom.
Wat is dit? Wat is dit? Wat is dit?
Sien.
Dog is nou in.
Hi, I'm Adam. This is the Machine Tech video blog, and today I'd like to talk a little bit about centrifugal press.
Kyk, ons gaan hy los vir 'n ander dag. Hy't boys, hy's ons ding vir die dag.